Hello all, welcome back. We're going to deal with the last unit of research methods and basic statistics subject, that is sampling design, tools of data collection and communicating research. I have put in a lot of efforts to make all the concepts of this unit very easy, and I have explained every answer very clearly in a detailed manner by providing lot of examples. You can see that this video is almost going up to 2 hours. And the notes that I have provided for this particular unit are also to the point and very easily understandable. So let's get started. First question, what are variables? Explain the type of variables. In statistics and research, the concept of variables is fundamental. Okay. Every research study, not only in statistics, any subject you take, is built around variables. Because what are these variables? They are factors that are studied, measured, and analyzed. So it is the variables that we are going to study in statistical research. Now, what is a variable? It is any characteristic, attribute, or quantity. It can be anything that varies or changes from one individual to group to situation or time to another. Okay. So what are variables? Variables are any values or quantity that keeps on changing. Okay. Variables, as their name itself suggests, they are not fixed. Okay, they keep on changing. Example, marks are variables as they differ from student to student. Study hours are variable. Each student requires different hours of study to complete a particular syllabus. And then intelligence students also vary. Intelligence in student also varies. So all these are examples of variables. Now, variables will help researchers to collect meaningful data, study the relationship between factors, test hypothesis. What is hypothesis? This term you're going to listen throughout the unit. What is hypothesis? It is assumption that is made before conducting any research. We will deal about this in detail in the further slides. But for now, you remember that hypothesis means assumptions. Okay. Also, variables help the researchers to draw scientific conclusion. This is the exact statistical definition of a variable. It is a measurable characteristic. Okay. It has certain value. Okay. It can be measured. It is a measurable characteristic that can assume different values under different conditions. Okay. Now, every variable in research, you have to remember that every research, there are two variables, independent variable and a dependent variable. Okay, the definitions I have given, the definitions and explanations I have given in the further slides. So every research has two kinds of variables, independent and dependent. Independent variable is also known as the cause variable. Dependent variable is also known as the effect variable. So we have seen the two types of variables are independent variable and the dependent variable. Independent variable is the cause variable, dependent variable is the effect variable. Okay, so what is independent variable? It is that which can be manipulated or changed or controlled by the researcher. That means independent variable is totally in the hands of the researcher to observe its effect on another variable. It is called independent variable because it does not depend upon any other variable, as the name itself suggests. Okay, it is a cause in the cause effect relationship. What are the examples? For you will clearly understand after you study the examples. Okay, first example is study hours affecting marks. Okay, so how will study hours affect the marks of the student? So study hours, a researcher, what he will do is he'll keep varying the study hours. Like first he will give 2 hours of study time. Okay, then how it will affect the marks of the student, he will observe. Then he will increase the study hours to 3 hours. Then how it will affect the marks of the student? So here study hours is being changed by the researcher. Okay, study hours is in the hands of the researcher. It is manipulated, changed and controlled by the researcher, and marks are coming automatically. It is not in the researcher's hand. Okay, so study hours affecting marks. Then teaching method affecting students' performance. Okay, how a teacher's teaching method will affect the student's performance. So teaching method is independent variable and performance of the student is dependent variable. Use of technology affecting learning outcomes. So how will technology affect learning outcomes? So technology is independent variable and learning outcomes are dependent variable. So study hours, teaching methods are independent variables here. Then dependent variable. Dependent variable is the effect variable. This is the variable that is actually measured or observed. Okay, this variable changes as the result of changes in independent variable. So we keep changing the independent variable and dependent variable keeps changing by itself. It is not controlled by the researcher. Okay, it is the effect of the dependent variable or it is the effect of the cause. Okay, example, marks obtained by the student. Marks are not in the researcher's hand. Only the study hours are in the researcher's hand. Then level of understanding. The teaching methods will will affect in level of understanding. Academic performance. All these are not in the researcher's hand. So these are dependent variables. So if study hours increases, marks will improve. So marks is a dependent variable. Marks is depending on study hours. Okay. I hope it is clear. Then the next type of variable is confounding variables. So confounding variable is additional variable that influences both independent and dependent variable. Okay, creating a confusion in the results. So confounding is confusion. Confounding means confusion, the variables that create confusion in the results. Okay, it makes it difficult. These confounding variables will make it difficult to identify the true relationship between variables. So let us see a small example. So, so we already know study hours, marks of a particular student are dependent on study hours. So study hours is independent variable and marks is a dependent variable. Clear till here? Next, when confounding variable, how it will come into picture. Intelligence is a confounding variable. This aspect of intelligence creates confusion in this dependent and independent variable relationship. How it will create confusion? A student will score high marks not only because of study hours but also due to intelligence. So it is this intelligence is making this study hours and marks relationship very confusing. So this third person came in this triangle. Okay. So not only due to, so in spite, even if he is given 1 hour of study time, an intelligent student might score good marks. So intelligence is a confounding variable. So it will confuse the relationship. Okay, it confounds the relationship. Okay, another example is exercise will help in weight loss. Okay, then again a confusing variable will come, that is diet. Okay, diet can also cause weight loss, not only exercise. Okay, so a confounding variable is one variable which comes in between the independent and dependent variable and creates a lot of confusion. Okay, confounding means confusion. Then categorical variable or qualitative variable. Okay, these categorical variables will classify the data into different groups or categories. They do not have a numerical meaning. Okay, they represent qualities or labels. Example, gender. It can be either male or female. Type of school. It can be either government or private. Blood groups A, B, AB, O. Okay. No mathematical operation can be done on these, right? So one cannot perform any mathematical operation on these categorical variables. They just divide the variables into different categories. Like when we talk about gender, there are two categories, male and female. When we talk about the type of schools, there is government and private. Okay. Okay, an educational example is classifying students into urban or rural. So basically, we are categorizing the variables. Okay, then continuous variables. So these continuous variables can take any value within a given range, including fractions and decimals. Okay, they are measurable and numerical. These cannot be measured. They do not, the categorical variables, they do not have any numerical meaning. They cannot be measured. But continuous variable, they take a value. That means they are measurable and they have a number, specific number. Example, height. It can have a number, right? Weight. It can be measured in kgs and it has a number. Then time. It can be measured in hours, minutes, seconds, and it has an appropriate number. Okay. So this is a continuous variable. Continuous is quantitative. Categorical is qualitative. Okay. That is a explanation. Then extraneous variables and demographic variables. What are extraneous means? Unwanted. Okay, they are not in the main focus of the study, but they affect the outcome. They are not visible outside, but they do affect the research outcome. Okay, these variables must be controlled to get the accurate results. They will not be seen in the picture. Okay, but they are very much necessary and they also have to be controlled. Example, in a study process, the teaching methods followed by a teacher will affect the marks of the students. So what are extraneous variables? They are not seen, but they are also very important. Like classroom noise. Then apart from classroom noise, student health. Though it is not visible outside, student health is very important. Then the mood of the teacher. Okay, it is not visible outside, but if the teacher is in a bad mood, then she might not teach properly. So they affect the performance but are not part of the study. Very important. Demographic variables. They describe the background characteristics of an individual. What is the background an individual comes from? They are used to classify and group the participants. Examples of these demographic individuals include age, gender, income, educational level, occupation, etc. So, students can be classified based on these variables. Okay. So, this is a summary table that I have provided for your clear and better understanding. You can go through. Since it is a big answer, for you all to easily remember, I have made a summary table. You can go through. What are the levels of measurement? Explain the 4 levels with characteristics and example. Okay, introduction. So in statistics, once the data is collected, it must be measured. Okay, a proper numerical value should be given to the data and it should be classified properly. Okay, the way we measure the data will determine what type of analysis we should perform on our research activity and what type of mathematical operations are possible on that particular research. So these classifications like the analysis and the mathematical operations and all the other measuramental classifications are called as levels of measure. So in simple words, level of measurement will tell us how a particular data that we have collected, how it should be organized, compared and analyzed. So what is the proper definition? The levels of measurement refer to the different ways in which variables are measured and categorized or classified based on their properties and their mathematical significance. So why are levels important? So that they help us in choosing the correct statistical methods. As we go forward, we will see many statistical methods. They help us to understand the nature of the data. What type of data did we collect? And they help us in performing correct mathematical calculations and they help us to interpret the data in the right way. In statistics, there are 4 levels of measurement. Okay, nominal scale. The first two are nominal scale and the ordinal scale. What is nominal scale? It is the simplest level of measurement that is used to classify data into various categories or groups. So we will see one example to identify what the simple kind of measurement scale is. Example, gender, male or female. Very simple. There is no complexity in this. Blood group, A, B, AB, O. Finish. There is nothing other than this. Then religion, Hindu, Muslim, Christian. Okay, so it is very simple and it will answer the question what type. Okay, male or female, A, B, AB or O, Hindu, Muslim or Christian. Okay, very simple kind of measurement. Okay, here what are the characteristics? Data is divided into various categories or labels. There is no order or ranking. There is no first, second, third, nothing. In male and female, you cannot divide it into first or second, right? It is male and it is female. That's it. There are no mathematical operations. Okay. Only counting is possible in some cases. Okay. What are educational examples? A teacher will record students as science, commerce, or arts. There is no comparison or no ranking, nothing. Okay. So nominal means only name, no order. Okay. The next one is ordinal scale. Ordinal scale not only classifies data, but also it will provide the rank or the order. If you see the example, in a class, students are ranked as first rank, second rank, third rank. Grades are given A, B, C. Then satisfaction level is good, average, poor. Okay. It will tell which is higher and which is lower, but not the exact difference. Like if you see in the classroom ranks, first, second, third, it is just giving first, second, and third. That's it. It is not giving how much first and second difference is there between first rank person and second rank person. How much difference is there? It is not telling. Okay. And it is not telling how much difference is there between the second and third. It is simply giving the order. Okay. Then what are its characteristics? Data is ordered and ranked. There is no information about the difference between the values and it cannot perform full mathematical operations. Okay. That's it. Just basic order is given and complex mathematical operations cannot be performed in ordinal scale. It is just one step higher than nominal, but it is not, giving us the full information. The third type of scale is the interval scale. It not only shows the order, but it also shows the difference between the values. Okay. Uh, some of the characteristics are between those values, the values are distributed in equal intervals. Okay. Differences between the values can be measured. Okay. There is no true zero. That means zero does not mean absence of that quality. Okay. If we see one example, we will get clarity. Okay. Addition and subtraction, that is basic mathematical operations are possible. Example, see, marks scored by students. Okay. So a particular student has scored 50 marks, 60 marks and 70 marks. So the difference between 50 and 60 is 10 and difference between 60 and 70 is 10. So as we have seen, the equal intervals are present between the values. But then if a person has scored 0 marks, that means that means he is not a dull student. Okay, that means there is no value for 0. Okay, see, here it is written no true 0 point. That means 0 marks does not mean the absence of knowledge completely. That means even if a person gets 0, that doesn't mean he doesn't have knowledge at all. Because of certain conditions like health or, various other conditions, he might have scored 0. But 0 means it doesn't mean that he doesn't have any knowledge at all. Okay, because of the conditions he has scored like that. Okay. There is no true 0 in this interval scale. Okay, so interval scale is equal differences are there, but there is no true 0. 0 does not have any value in interval scale. Okay. Then ratio scale is the highest level of measurement. Okay, it has all properties. Any mathematical operation can be possible. It has classification, it has order, and the values are distributed in equal intervals and true 0 point. That means 0 has certain value in this ratio scale. Okay, That means it has some of its characteristics are it has absolute or true zero. That means zero has certain value. Okay, but in interval scale there is no meaning for zero. Okay, and all mathematical operations are possible and ratios are meaningful. Example: height, weight, time, income, etc. Some so study hours as an example, study hours 2 hours, 4 hours. So 4 hours is twice the 2 hours. Okay, it can be mathematical into 2. Multiplication has been done. Okay, so ratio means everything is possible and zero has a value. That means true zero is there. Whereas in interval scale, equal differences are there, but zero has no value. Only simple addition and subtraction can be possible in interval scale, whereas in ratio, everything is possible and zero also has value. This is a small summary table you can go through. Difference between descriptive and inferential statistics. So what is descriptive statistics? It is a set of methods. Okay, it is not just one thing. Okay, it is a set of methods that are used to organize, summarize and present data in a meaningful way. Okay, it describes the main features of the data without making any predictions. That means it will explain whatever is there. It will not generate hypothesis, or it will not make any guessworks, or it will not do any kind of assumption. Whatever is there, the descriptive analysis or descriptive statistics will use various methods to make it more clear and make it more understandable, and it will explain everything. So it will help us to understand large data very easily, present data in a very simple form, and it will identify patterns and trends in the data. So simply it will answer what is happening in the particular data. Okay. So some of the ways, uh, some of the descriptive techniques used are measures of central tendency. You have studied this since young age. So what are the, there are three measures of central tendency: mean, median and mode. What is mean? Mean is the average. That is the sum of all the values divided by the number of the values. Okay. Mean is sigma x by n. Sigma x is the sigma x is the summation of all the values. N is the total number of values. Okay. Then this is the example. Three values are given. 40 plus 50 plus 60 by how many values are there? Three values. So 150 by 3, that is equal to 50. So average marks is 50. Then median. What is median? Median is the middle value when data is arranged in order. This is very important. When data is arranged in order only, we can calculate the median, either ascending or descending. Okay. So for example, we have taken 30, 50, 70. What is the middle value? This is very simple. 50. 50 is the middle value. That is the median. Suppose if there are, let's say, uh, four values or some even number given like A, B, C and D. What is the middle value in these four? You cannot tell the exact one middle value, right? So what you'll do is you will take the center two values. You will add B plus C by 2. So this will be the median. So the center two values you will add and divide it by 2. That is, you are taking the average of these two values. So that is the median for even numbers. Median for odd numbers, directly you will have a middle value that you can take and call it as the median. Mode is the value that occurs most frequently. That is, let's say in this example, 50 is occurring multiple times. So 50 will be the mode. Okay. Then another way of descriptive statistics is graphical representation. That is, you are representing the data in the form of graphs. So there are many types of graphs. So some of them are histogram, pie chart and box plot. Histogram is nothing but it is a frequency distribution table. That is, it will tell the number of times. Okay, frequency is the number using continuous bars. Okay, I will show you in the next slide the pictures of everything. Each bar will show how many values will fall within a specific range. Example, Marks group between 0 to 10, 10 to 20, all these are represented in the form of bars. Okay. Then one more is pie chart. Pie chart is a circular diagram that shows a whole parts of a whole, like a complete thing will be there and parts from that complete thing will be shown. Example, uh, students choosing subjects: science 40%, commerce 30%, arts 30%. So in a big circle, 40, 30, 30 will be divided in a circle. Then box plot. Box plot is a graphical representation that shows how data is distributed by dividing it into four equal parts. These four equal parts are called as quartiles. Okay, and it will help to identify median, spread of data, and extreme values, that is the outliners. Okay, any value that is deviating from the average, that is extreme negative value or extreme positive value. Okay, I will just show you the pictures of all these. So this is a histogram. Everything is represented in the form of bars, rectangular bars. This is a pie chart where this is full circle is the whole, and each of them are divisions. Like for example, this blue color represents children who like ice cream. This maroon color represents children who like toffees. Okay, both of them are equal, 4, 4. Okay, this then uh, children who likes popcorn is this green part, and this children who rides various rides is orange part. So this whole is mm, divided into various parts. Okay, then this one is box plot. Okay, so this is a box. Okay, that box is present between this 50 to almost 85 to 90 range. Okay, then the middle value is the median. This the highest value side is called the upper quartile, and the least value side, the lower value side is called the lower quartile. And anything which is going beyond the lower quartile and upper quartile, that is extreme low values and extreme high values, are called as the outliners. Okay, these are the extreme values. Okay, this is the box plot. Then measures of dispersion. There are three ways to measure dispersion: range, variance, and standard deviation. Okay. Range is the, so measures of dispersion basically show how spread out or scattered the data is. That is how, what range, what area the data is occupying. Okay. In what way it is spread out. Okay. First way to measure the dispersion is range. Okay. Range is nothing but the difference between the highest and lowest values in a given data set. Okay. In a particular data set, highest value is 80 and lowest value is 20. So what is the range? 80 minus 20, that is 60. Okay. So range is highest minus lowest. In symbols, how you can tell it? X max minus X min. Then variance measures how far each value will deviate in a particular data set, how far each value will deviate from the mean. Okay, we calculate the, in a given data set, we calculate the mean, and then how far, what is the difference from of a particular value that we have taken, how it is, how much is it different from the mean value. Okay, then the standard deviation is the square root of variance and shows how much the values differs from the average. Okay, for this is a very, you have no other choice but to learn this formula. Formula for standard deviation, sigma, is this one. Okay, see this, all these are the explanations of the variables in the formula. Okay, where is the descriptive value, descriptive statistics applied? It is applied in business, healthcare, and education. So all these involve a lot of data. So descriptive analysis is useful in all these fields. Then what is inferential statistics? We have done with descriptive statistics. What is inferential statistics? Okay, inferential statistics is used to draw conclusions. As the name itself tells, inference, it is used to draw conclusions. Whereas descriptive stat, it is used to make predictions and generalize results about a population based on a sample. Okay, whereas descriptive analysis, descriptive statistics, it is just explaining whatever data is there. It will not make any assumption, it will not make any prediction. Whereas inferential statistics, it will draw conclusions, it will make predictions, and it will generalize results about a population. Okay. So inferential statistics goes beyond data collection. It is highest level and it will help in making decisions and predictions. Okay, what question this will answer? What can we conclude or predict from the data? Okay, so some of the key points in inferential statistics are estimation. Okay, estimation is used to predict the population values based on the sample data set. Okay, so in this estimation, this estimation is basically used to predict the values of the population based on a given data set. Okay. So this estimation is divided into point estimation. Okay. It gives a single value as an estimate. Just direct to the point. As the name itself tells, to the point. It gives a single value as an estimate. Example, average marks of students is equal to 60. Say finish. Just to the point. Interval estimation. Interval estimation will give the range of values. As the name itself tells, it will give a range of values. Okay. In this range of values, the true value lies. Exactly the value we do not know, but from this point to this point, the value, the true value will lie. Okay. That is interval estimation. Example, the average marks will lie between 55 and 66. Okay. We do not know the exact marks, but we only know that the marks will lie between 55 and 66. Okay, whereas point estimation, it will give the exact value. Okay, it will predict it or it will estimate the exact value. Then there is one more thing in this inferential statistics, hypothesis testing. What is hypothesis in the first place? Hypothesis in layman's term or in common language is also known as assumption. Okay, we are testing the assumption that we have made. Okay, hypothesis testing is a method used to test the assumptions that have been made about a population. Okay, hypothesis is divided into null hypothesis and alternative hypothesis. Null hypothesis is represented as H0. Alternative hypothesis is represented as H1. So what is null hypothesis? It will state that there is no relationship or no effect. Okay, it will, null hypothesis means there is no relationship between two variables that we have taken. Example, study hours and marks are two variables we have taken. Null hypothesis states that study hours do not affect marks. Okay, it will tell that study hours will not affect marks. Only intelligence will affect marks. Okay, there is no connection between study hours and relationship. Is what null hypothesis will tell that there is no relationship between study hours and marks. Then the next one is alternative hypothesis, that is represented as H1. It will tell that there is some relationship or effect between the two variables that are being taken. Example, study hours will affect marks. Okay, null hypothesis, alternative hypothesis will tell that there is a relationship between both of them. Then comes a p-value. Okay, p-value is, the p means probability. Okay, it will indicate the probability that result occurred by chance. Okay, any result that if the researcher has got any result, then p-value will tell that that value which the researcher got is by probability or by mere chance. Okay, so in hypothesis testing, you should remember null hypothesis, alternative hypothesis, and p-value. Then there's one more term you have to remember is significance level. Okay, it is a standard value. Significance level alpha is a standard value. Okay, it is usually 0.05. Okay, the significance level will tell us whether to accept or reject a particular hypothesis. Okay, significance level will tell you how important the hypothesis or the assumption we have made, and whether based on the importance, whether we have to accept that hypothesis or reject that hypothesis. That is a significance level alpha. Then there's one more important thing, the regression analysis. The regression analysis is a statistical method that is used to examine and measure the relationship between a dependent variable and one or more independent variables. Okay, So it is also used to predict the value of dependent variable based on the value of independent variable. That means from this definition you should understand that regression analysis will provide a numerical value to dependent and independent variables. We have seen dependent and independent variables before, but regression analysis will provide clear cut numbers. It will provide measurement to dependent and independent variable. It will measure the relationship between both of them in numbers. Okay, so this regression analysis is divided into simple linear regression and multiple regression. What is simple linear regression? It will study the relationship between one independent variable and one dependent variable, just one. Okay, that means example is study hours, how it will affect the marks. Okay, study hours is one independent variable, marks is one dependent variable. So here I want to add a point about regression analysis. The value of dependent variable will be based on the value of the independent variable. Okay, that you have to remember in the definition. Okay, then the multiple regression is it will study the relationship between multiple independent variables and one dependent variable. Remember, only one dependent variable is there and other multiple independent variables are there. Example, marks. Marks is a dependent variable, only one. And then what are the independent variables? That is study hours, intelligence, and attendance. So how these study hours, intelligence, and attendance will affect the marks? So here all these three are independent variables which are multiple. Okay. So simple linear regression and multiple regression. Simple linear regression, one independent, one dependent. Multiple regression, multiple independent and one dependent. I hope you understand the difference between both of them. Okay, so once again I'm telling you, I'm clarifying you. Regression analysis will measure, that is, it will provide a numerical value to dependent and independent variables. Okay, how is this? What is the applications of inferential statistics? So you remember one thing, inferential statistics is used wherever prediction is involved. So which areas prediction is involved? Market research, clinical trials, and engineering. So all these are which involve prediction will involve inferential statistics. I hope I am clear. If you have any doubts, please mention it in the comment sections below. I will find some or the other way to clarify your doubt. Please go through this summary, that is the difference between the descriptive and inferential statistics based on the explanation that I have given previously.